Children, you all know that general form of a pair of linear equation in two variables is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Okay. Now any equation can be considered as equation number 1 and the second equation can be considered as equation number 2. But this will be the general form of pair of linear equations in two variables. So now children, in exercise 3.1, you have represented the equations on the graph and you observed that in the first question you obtained intersecting lines. In the second question, the lines were coincident or overlapping. In the third questions, lines were parallel. Now children, the question is, after making the graph, so we can see the graph and say what type of lines are there. But is there any method that before making the graph we are able to we are able to tell what type of lines are going to be there? Now children, as I have told you earlier also, mathematics is mathemagic also. There are many things which work as a magic in mathematics. So among them, one of them is condition of consistency for a pair of linear equations in two variables. Now what are these conditions? These we are going to discuss today. So children, see, without making the graph, if we are asked what type of lines are going to be there, so how can we tell that? So children, for that we will check the coefficients of x, y and the constant term, right? Now as you know, the coefficient of x is called a1 and a2. Coefficients of y are called b1 and b2 and constant terms are called c1 and c2. Now if you want to see what kind of graph is going to be there, what are we going to do? We are going to take the quotient of a1 and a2, like we are going to divide a1 and a2. a1 upon a2 we will see, and also we will check what is b1 upon b2. For any pair of linear equation, we will check what is a1 upon a2, what is b1 upon b2. And if they are not equal, we will not check for c1 upon c2. Okay. So if they are not equal, what are we going to say? The lines are going to be intersecting lines. Okay. So if a1 upon a2 is not equal to b1 upon b2, lines will be intersecting. And you know that you have learned that how do we get the solution on the graph? The point where the lines intersect, that point is called the solution. So if the lines are intersecting, there is going to be unique solution. Unique solution means one solution. There is a solution. And now comes consistency. What is the meaning of consistency? Consistency means, do we have something in this pair system of linear equation? In this pair, do we have something? So they are called consistent. Consistent means they have the solution. They consist something. So they are called consistent. Now, again I repeat, a1 upon a2 and b1 upon b2 we will check. If they are not equal, that would means lines are going to be intersecting. And if the lines are intersecting, there is a unique solution. And if there is a solution, that means the pair is consistent. Now, if a1 upon a2 and b1 upon b2 you get equal, if a1 upon a2 and b1 upon b2 are equal, then we will check for c1 upon c2 also. So if all three are equal, then you are going to get coincident lines. The lines will be coincident, because this would mean that both the equations are same. If they are same, you are going to get only one line. That is why in the second question you saw the lines overlap. So these type of lines are called coincident lines. And you know, we get the solution only if the lines intersect at a point, and here the lines are coincident. They are intersecting each other throughout. So that means there are infinitely many solutions. And because there are solutions but we do not have a unique solution, so this type of system is called, it is consistent, it has something but dependent. Consistent and dependent. Once again I'll show you. If A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, we are going to get coincident lines, and there will be infinitely many solutions, and the system will be consistent and dependent. Now children, if A1 upon A2 is equal to B1 upon B2, but it is not equal to C1 upon C2. These two are equal, but when we checked for C1 upon C2, they were not equal. This would mean lines are going to be parallel. And as you know that parallel lines do not intersect each other anywhere, that means we will have no solution. And if we will have no solution, that would mean the system is inconsistent. Okay? It doesn't have anything, so no solution is there. It is inconsistent. I hope you have understood the conditions of consistency. Now I am going to explain you question number 2, first part to you, and after that you will be able to do all the remaining questions yourself. So this is the system, this is the pair of linear equation. 5x minus 4y plus 8 is equal to 0. 7x plus 6y minus 9 is equal to 0. Now, first of all, we are asked whether the lines will intersect at a point, or they will be parallel, or they will be coincident. So, without making the graph, we have to answer this question. So, what are we going to do? We are going to first of all check what is A1 upon A2. As you know, the coefficient of x are called A1 and A2. So, A1 upon A2 will be 5 upon 7. Now, what is B1 upon B2? Minus 4 upon 6 is B1 upon B2. So, B1 upon B2 is minus 4 upon 6, and after the cancellation we get minus 2 upon 3. So, we are not, if they are not equal, so we will not be checking for C1 upon C2. Okay. Now, A1 upon A2 is not equal to B1 upon B2. This would mean if A1 upon A2 is not equal to B1 upon B2, that means what type of lines we are going to get? We are going to get intersecting lines. So that is why the lines representing the given pair of equations will intersect at a point. This is our answer. I hope this is clear to you.